Welcome students, welcome to Crack Academy. Today's subject will be slope fields. Throughout your calculus career, you're probably gonna see it at least a little bit. However, slope fields is the main name for them. However, you may see direction fields or vector fields. Either way, they're the same thing. Just make sure those are in your vocabulary. If you see them on tests, slope fields should automatically pop in your mind. So, slope fields, it's basically a tool to graph or graphically obtain the solutions to a first-order differential equation. So, in other words, it's basically to get a sense of what the solutions might look like if you don't know how to find the solutions. It's a really helpful tool. Unfortunately, we just don't use it all that much. And also, you can use it for visualizing the slope if a solution goes to a certain point. And I'll explain this in a couple minutes, but you'll see later what I mean by that. So we'll go right into it with some examples. So the first one, we have the equation dy dx equals negative x divided by y, and then specifically through the point 0, 2. So what this means is through this equation, it will go through the point 0, 2, which we have to make sure it does. So I already have out our XY table, which you don't have to do, but I recommend it. It'll help you keep everything organized and then later help you with your graph. So you have your equation, you have your XY points. So all you're going to do is plug in negative 2 for X and 2 for Y and so forth. And I recommend you pause the video and try this for yourself, or if not, you can just follow with me. Alright, so assuming you did it by yourself, let's see if you have it right. So plug in negative 2 for X, you get positive 2 divided by 2 is 1. And then you would just do that so forth. So I'm just going to do them all real quick. Hopefully this is what you got. If you didn't, I'm sure Mr. Crack would love to help you with it. So anyway, next thing we're going to be doing is graphing it. So, it's basically everything we know how to do. So, you're going to go to the point negative 2, 2, and then we found the slope of that point is 1. So, negative 2, 2, and the slope of 1 is right about there. And say if it was 2, it'd be more steep, negative 1 be going the opposite way. And we'll see that in a little bit. Alright, so now we go to negative 2, 1, and we see it's 1/2, so it's going to be a little less. 0 is 0. Negative 2, negative 1 is negative 1/2. And then negative 2 is negative 1. We kind of see a pattern. It's the opposite on both sides of the quadrant, and you'll see that a lot in equations. So you may be able to fly through them just by doing that. Right. And then we know zeros are all blank. I'm just going to fly through this real quick, guys. Okay, so that's roughly what it's going to be about. And then before you graph and draw your lines or anything, you still have to keep in mind the point 0, 2, which means the differential equation has to go through that point. So looking at the slopes and the way it's all formed, we know it's probably going to be a circle. I'm going to start at 0, 2 just so I know I go through that point. I'm just going to follow all the slopes. And that's telling me it's a circle, following all the slopes of every point, and I went through my point 0, 2. So that is one example. Alright, and we're back. And if you're still watching this video, you probably really need some help. So, I'm going to go through these examples with you. Hopefully you can pause the video and try them by yourself and match up these equations with the following graphs. So here we go. So let's start with A. Pretty self-explanatory. Looks like all the slopes are 1. Based on the equations, I would say y equals x, which is number 1, looks the best. Let's just label that. Cross that off. All right. And C and D look interesting. We see that they're kind of like a wave. They're something we should be familiar with. Looks like sine and cosine, those are options. So let's start with C. We see that on the y-axis is all 0 compared to the y-axis on D, which is 1. We know cosine of x always starts at 1. And say if we were trying to say C was sine, it wouldn't be possible because sine doesn't start at 1. So I'm going to go ahead and put 4 for sine, or for C. Technical difficulty. All right, crossed off. D, we know sine starts at 0, which this graph does, and we know it goes up and then down. And same thing this way, which looks like a sine graph. And let me fill in these for you. I forgot to do these. To continue this graph, sorry about that, folks, it would continue to go up. And that looks like cosine to me. All right, and then through process of elimination, we know B would be 2, which is y equals 1 over x squared. And it would look something along these lines. And this one would be 3. Alright, hopefully this video helped you and got you a little practice. Yet again, any questions, Mr. Crack will be glad to help. Casey Rakers checking out.